Hi, my name is Michael Sullivan. I wanted to speak with you for a few minutes on a powerful pedagogical tool that has truly enhanced my classroom. Learning Catalytics is a bring-your-own-device, web-based clicker system. I've been using Learning Catalytics in my classrooms for the past year and a half. Essentially, I create modules for each class session. The modules are created by writing questions that assess the student's understanding of the content and concepts. That is, some questions are essentially meant to verify students understand computational aspects of the material. Other questions are more thought-provoking and assess the student's conceptual understanding of the material. What I really like about Learning Catalytics is that there are a wide variety of question types. The program goes well beyond multiple choice clicker questions. In quantitative disciplines such as calculus, pre-calculus, or statistics, the course demands more elaborate question types, and Learning Catalytics allows an instructor to ask such questions. For example, I just wrote a problem in Learning Catalytics that required the students to draw vectors for my pre-calculus students. The student uses their mouse or finger to literally draw the vector on their screen. I can also require algebraic expressions for answers. Because Learning Catalytics has a built-in computer algebra system, it can identify equivalent answers, which is amazing. My favorite question types are numerical, algebraic expression, region, sketch, composite sketch, multiple choice, and direction. With region questions, students click or touch their screen to indicate a point on an image. The author draws one or more regions on the image that defines what answer should be considered correct. With composite sketch questions, students sketch a graph using their mouse or by touching their screen. The results are displayed as a single composite sketch with each student's individual sketch overlaid semi-transparently on top of each other. This format works well with large classes when you want to get an overall sense of the common themes among sketches. With the sketch feature, students sketch a graph using their mouse or by touching their screen. The results are displayed as a tiled set of individual student sketches. So this format works better for smaller classes or when you want to be able to look at individual student sketches during class. With direction problems, students graphically draw an arrow or vector indicating a direction. With numerical response questions, respondents enter a numerical value. You may optionally set tolerance to accept the range of responses as correct. With algebraic expression questions, students enter a mathematical expression using a keyboard and, if enabled, the math palette. Again, a computer algebra system automatically scores expressions as correct when they are algebraically equivalent to the correct answer you provide. With multiple choice questions, it's your pretty standard multiple choice scenario where you set a variety of distractors along with the correct answer. Bear in mind that you don't need to write your own questions in Learning Catalytics. There is a library of questions available for instructors to choose from. The library grows daily as more instructors contribute their questions to the library. When you build your course, you need to decide on a module type. Modules include instructor-led synchronous, automated synchronous, self-paced, self-test, and team-based assessment. Personally, I use instructor-led synchronous models in my classes. In this module type, the students respond individually to questions as they are delivered one at a time. This model could also be used in an online environment with the instructor present. Essentially, I deliver questions to the students individually. I monitor responses using a seating chart. If between 30 and 70% of the students get the problem correct, I reassign the question after grouping the students in groups of 2 or 3. I tend to assign groups where students have different answers. This grouping is done automatically by the Learning Catalytics program. This grouping helps to spark discussion. Students will then submit their response to the question after their discussion. Most times, the class determines the correct response. At this point, I have a student explain the approach to solving the problem and sometimes have the solution put on the board. This helps develop communication skills in the students. If less than 30% of the class gets the problem correct, I know there is a problem, so I use this as an opportunity to lecture about the topic in that problem. If more than 70% get the problem correct, I allow a student who got the problem correct to explain the solution, once again resulting in peer-to-peer instruction. Because Learning Catalytics allows faculty to obtain real-time responses to a wide variety of question types, the feedback provided by the system allows me to adjust my teaching method and provide more instruction in areas of misunderstanding. In addition, the system allows for purposeful peer-to-peer interaction by carefully assigning students to groups based on each student's level of understanding. It's worthwhile to watch a video of my class in action. So right now, I assigned a question to the students and they're all working individually on the problem.
Alright, so find your partners.
At this point, I had between 30 and 70% of the questions correct, and so I reassigned the problem based on grouping. The grouping is in groups of 2, where the students each have different answers. The program tells the students where to go find their partner, and then they work on their small group. It's worth noting that this is a class that meets Monday and Wednesday from 8 to 9:50 in the morning. It's currently 8:45 on a Monday morning, and you can see the level of activity in the classroom. One other thing to note about this is that the classroom is full. Learning Catalytics encourages attendance because the students know that they're gaining a massive benefit by attending class. Learning Catalytics has allowed me to use the inverted or flipped model in all my classes. I only lecture on material that I know students do not understand. Again, this frees up time to get into deeper discussions about the material because I'm not wasting time on understood material. So my students are continually engaged. The peer-to-peer instruction that takes place in my classes has helped both the strong and the weaker students. Of course, the strong students benefit by serving as the teacher, while the weaker students benefit by learning about the content from a different perspective, the perspective of a peer. My retention rates have gone up and failure rates have gone down as a result of flipping and Learning Catalytics. I cannot imagine teaching without this program.